Okay, folks, what we have here is a B&K 1477. It's a 15 megahertz scope, and as you can see, it's in very good condition. Front panel is very clean, scratch-free. The window is very shiny and bright. The trim is clean, no dents, no scratches. Cabinet looks good. No scratches on the cabinet surface. It also is very clean. It's been taken care of. Very happy with that. And it's responded very well to internal cleaning and to calibration. Give you an example here. Right now you're looking at a just the zero trace with the ground, the vertical switch in the ground position. And if you watch, you'll observe what happens to the position of the trace as I switch lower and lower through the settings. All right, that's one setting. 2, 3, 4, 5, 6. That is the lowest setting right there. That's 0.01 volts per centimeter. And what you noticed, you may have seen the line shutter. Nothing you can do about that, but the position of that line relative to the grid changed like almost not at all. That doesn't happen by accident. Vertical was calibrated very carefully, and the zero doesn't shift. Now it's the same thing on both channels. If I switch to channel B, we'll move that so you can see that on the gradical. We'll do the same thing here. And like right now I am in position B, and I'm going to change the switch setting on this, and if you listen carefully you'll hear it. And we are in the lowest position right now. So once again, it doesn't happen by accident. The other thing you'll notice is that there is an absence of any noise on the traces. I'm switching through the positions. That's because the switches have been carefully cleaned internally. I carefully used chemically doped Q-tips and made sure I left no residue behind. And it's in good shape. Now, the next thing to do would be to demonstrate the operation of the unit, and we can do that. Let's see, take a look here. What we're looking at here is it's a pyramid, a step pyramid. Consists of 10 steps up and 10 steps down, 3 volts from the bottom step to the top step. And what we want to do is, if we know that when we're zeroed, the zero is correct, and we know any point on the scale what voltage it represents, then as long as we can demonstrate linearity in between in between the scale, then the scope is calibrated and provides a linear trace. So we're gonna go through that as an exercise to show that this scope is calibrated. Intensity-wise, there is a lot of intensity left in this scope. Here I've raised it up to maximum, and then I'll take her back to minimum, and then we'll come back up to a reasonable level. Focus also works. I can get it right down to a razor thin line there. And triggering is also in good shape. I mean, I can take her out, lock her in, Change the polarity of the slope. I can make the source go off of A if I want. I can make it go off of B if I wanted, or I can bring it in on the external, which I'm doing right here at the moment. Okay, let's give it some tests.